Going to cover lesson 77. Lesson 77 has to do with the binomial expansion. And so we're going to start, this is a review from Algebra 2, but we're going to start with Pascal's triangle. And I should have written, there are some shortcuts to expanding a binomial. And so a binomial is when we have two terms and our exponent can be n. So Pascal's triangle begins with a 1 on top. And then the next row is two ones. Notice I spaced it so that it forms a triangle. Now the pattern for every row from here on out is every row begins with a 1 and stagger it to the left. And then the sum of the two numbers above equals the next number. So 1 plus 1, this is 2, and ends with a 1. Next row, every row begins with a 1, but the next number is the sum of the two above. So 1 plus 2 is 3. 2 plus 1 is 3, and every row ends with a 1. And we stagger it so that it forms a triangle. So the next row begins with a 1, the sum is 4, the sum is 6, the sum is 4, the sum is 1. And we can keep going indefinitely. So 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, and 1. And so on. This goes on and on and on and on. But we need to recognize a couple things. These rows correspond to coefficients in our binomial, and each of them has a value. So if you'll notice, I wrote in here. Each of these rows in Pascal's triangle has a value for n. So for row 1, this is when n equals 0. The next row is when n equals 1, when n equals 2, when n equals 3, when n equals 4, when n equals 5, when n equals 6. And hopefully you notice it corresponds, like if you look at this diagonal of numbers, n equals 1, 2, 3, 4, 5, 6. So like in row 4, there should be some 4s, okay? Also, each row corresponds to a combination. So a combination looks like this, NCR. So this top number, n is 0. So this is 0, C, 0. And if you were to enter that in your calculator, you would get a 1. This next row, n is 1. So 1C, 0. This would be 1C, 1. This next row, n is 2, so this would be 2C0, 2C1, 2C2. This next row, n is 3, so 3C0, 3C1, 3C2, 3C3. And remember, these have an equivalent value. So if I was to enter 3C2, I should get 3. So 3, whoops, I have to turn it on, 3C2, and I get 3. So they have an equivalent value. So this next row, n is 4. So this is 4C0, 4C1, 4C2, 4C3, 4C4. Next row, you should start to see a pattern, 5C0, 5C1, 5C2, 5C3, 5C4, 5C5. And this would keep going. This is 6C0, 6C1, 6C, all the way right to 6C6. So hopefully you see the pattern. Everything begins where R is 0 and it ends where these numbers are the same. Okay, so I'm just going to fill this in and then we're going to do a couple examples. So example using Pascal's triangle. So number 1, expand x plus y to the 6th. So I'm going to move this up a little bit. Now, I prefer Pascal's triangle when I'm expanding because I don't have to use my calculator. And so because n is 6, I'm going to use the numbers from that row. Okay, so I'm going to use 1, 6, 15, 20, 15, 6, and 1. So reminder on how to set it up. You grab the number from Pascal's triangle, and then each term goes in parentheses, and then a plus sign, and then the next number in Pascal's triangle, and each term in parentheses, and then the next number in Pascal's triangle, and then each in parentheses, plus 20, each term in parentheses, plus 15, each term in parentheses, plus 6, each term in parentheses, plus 1. Then you will assign your exponents. So beginning with x, I'm going to start with n, so 6, and then I'm going to list it in descending order. So x to the 5th, 4th, 3rd, 2, 1, and 0. And anything to the 0th power is 1, so I'm just going to go ahead and cancel that. The exponent belonging to y should move in the reverse direction because the sum of exponents has to equal whatever n is. And in this case, n equals 6. So 6 plus 0, 5 plus 1, 4 plus 2, 3 plus 3, 2 plus 4, 1 plus 5, 0 plus 6. And again, anything to the 0 is 1. So I'm going to simplify each term. This 1 times x to the 6th, right, is just x to the 6th. Next term, 6, so positive 6x to the 5th, y, plus 15 x to the 4th, y squared, plus 20x cubed, y cubed, plus 15x squared, y to the 4th, plus 6x y to the 5th, plus y to the 6th. And so this would be my answer. And I'm just trying to take really good and so this is my answer. All right, so moving on. Now let's try expand m minus 2n to the 4th. So do a little bit more of a difficult one. So in this case, I have a 4. So going to where n equals 4, I'm going to be using these numbers. So I'm going to be using 1, 4, 6, 4, 1. So here is how we'll set it up. 1 times m times negative 2n. Then 4 times m times negative 2n. Plus 6 times m times negative 2n. Plus 4 times m times negative 2n. Plus 1 times m times negative 2n. Then we'll assign our exponents. So starting with n, so 4, 3, 2, 1, 0. And then in the reverse order, 0, 1, 2, 3, 4. And then from here, we're going to simplify. So this first term is just 1 times m to the 4th. But this next term is 4 times negative 2 to the 1st. So I get negative 8m cubed n. Remember, our sum of our exponents has to equal n. So 4, 3 plus 1 is 4. Next one, this is 6 times negative 2 squared, which is 4. So 6 times 4 is 24. M squared, which means n has to be squared because 2 plus 2 is 4. This next one is 4 times negative 2 to the 3rd. Negative 2 to the 3rd is negative 8. So negative 8 times 4 is negative 32m. And then n cubed, right? Because this is a 1. And 1 plus 3 is 4. Last, this is a negative 2 to the 4th. So that gives me a positive 16n to the 4th. And this, my friends, is our answer. All right, next page, when I'm looking for a specific term. So number 3, find the fourth term of x plus 3y to the sixth. So when I'm looking for a specific term, this is where it's very helpful to use the combinations. So fourth term, so I'm going to set it up. I know n is 6. So 6C0, 6C1, 6C2, 6C3. I'm going to stop, right, because this is first, second, third. There's my fourth term. So I have 6C3, and then I would have each term in parentheses. Now I remember, if it helps you, right, the first, this would be x to the sixth, x to the fifth, x to the fourth, x to the third. So this should be to the third. And I know their sum must equal 6. That's one way to do it. Usually anytime this exponent, the second exponent should match r. So this second number should match the second number up here. And then I would simplify each one. So in my calculator, I'm going to enter 6C3. That gives me 20 times x cubed times 3 to the third, so that's 27 times y cubed. So 20 times 27 gives me 540. So my term is 540 x cubed y cubed. Next, find the sixth term of y minus 2 to the 8th. All right, so sixth term, and I know that in this case, n equals 8. So 8C0, 8C1, 8C2, 8C3, 8C4, 8C5. So 1, 2, 3, 4, 5, 6. So I have 8C5, y negative 2. I know this number and this number should match. And so 5 plus what is 8? 5 plus 3. Okay. You could have also, that's one way to do it. You could have also written the y's in descending order, like y to the 8th, 7, 6, 5, 4, 3. So y to the 3rd. All right, so I'm going to simplify this. So 8C5 is 56 times y cubed times negative 2 to the 5th. 56 times parentheses negative 2 to the 5th gives me negative 1,792 y cubed. And that pretty much covers this section for homework. 77, you're going to skip numbers 2, 4, 6, 25 through 27, and 30. Thank you.